what the strategy is, we're going to try to we will try to put our nonlinear equation into this form. So we want to, I'll call this like, say, a capital Y equals M capital X and call this maybe capital B. So it sort of looks sort of like a linear equation, except like, say, this is a function, not just X. This is a function. And this is a constant, so going to be our slope. And then this is constant. So we're going to try to take our equation and put it into this form. And I'll sort of actually calculate the line sort of by hand on the first couple of them. So let's suppose we wish to fit, say, this data to let's say an equation like this. Call this maybe C1 X plus C2 X cubed. That's what we'd like to do. We're going to fit it to this. Now, obviously, this is not a linear equation because it has a cube in it. So we want to try to convert this to a linear equation. So solution. We want to try to get something in sort of in this form here, where we have a function on the left, we have a constant times a function plus a constant. So I guess there's a couple ways we could do this one here. We can maybe divide by X. So divide by X, say this equation here. What's that going to give us? That's going to give us Y over X equals, and this will just go to be like a constant. And that'll be, say, C1. Then we divide this over here. This will be plus C2 X squared, like that. We divide by X. Or if you want to kind of just rearrange it like I had it a minute ago, Y over X equals C2 X squared plus, say, C1. So now that kind of matches the form that we had. So like here, again, this is going to be our capital Y that we had in our equation over here. And then this is going to be our capital X. And then this is going to be our constant, like this. So now we need values for Y and for X now. So we're going to have to generate those. So we can make a little table. So again, now y is going to be like our y over x. X is going to be like our x squared. So let me actually sort of rewrite the table that we had. Let's say this is going to be x and y. And then that, and I'll write down our original data. And this is 4, 170, 6, 300, 8, 550, 12, 1150. And then our capital X, we're calling that x squared. So let me put this up here. So our capital X here is going to be x squared. And our capital Y over here is going to be y over x. Again, we're using those because we turned this into a linear equation. Again, this is our y value. This is our x value. So now we just calculate these. And so this is just going to be x squared, which is 4 squared, 16. This is going to be 6 squared, 36. 8 squared, 64. And 12 squared, 144. And then y over x is going to be, again, 170 divided by 4. When you put that in your calculator, you get like 42.5. And then 6 over 300, excuse me, 300 over 6 is 50. 64, excuse me, 550 divided by 8 is 68.75. And then 144 divided by 12 is 95.833. So we have these values here. And now, so these become our capital X and capital Y. So you could go through and calculate them the way we did the other day, or you could put them in, put everything in Excel. Let me just kind of do it. Let me see how, if yeah, I sort of did it by hand, but let's say you put these values into Excel. So put into Excel. And this is going to be these are going to be your X values. These will be your Y values. And so when you put those into Excel, you get that the slope M is 0.4186. And you get the y-intercept, which is like B, which is going to be 37.065. So now again, we did this and we were using this capital X and capital Y. So what we found then were the coefficients of this equation. So that the m that we just found here is going to be this 0.4186. And then the y-intercept is going to be this 37.065, like that. But now to get back to the original equation, remember what y was equal to. Y was equal to, the capital Y was equal to y over x. So we'll put that in here, y over x, small y over x. And capital X was equal to x squared. But then finally, the equation we start out with was y equal, then so multiply through by x. And we get that. So any questions on this? Now, again, there are certain times when you'll go through the process and you won't get very accurate results. So there's some things you have to kind of watch out for. Though this is a quick way to turn a nonlinear problem into a linear problem, and then use this on Excel. And let me try a couple more here, just to give you a feel. Any questions on this one? Let me do a couple more. Let's try. So again, let's say you have this. So you have x, y, 218, 459, 7160, 9250. And fit this equation. Y equal, let me call it again, C1 x cubed plus x plus ax squared. So we want to fit this data. Once again, we need to have kind of that more general form of y equal mx plus b. So again, you could probably, I suppose you could really try this either way. I'm not sure. Probably dividing by x squared is maybe the most logical, but let me try it the other way. So if we divide by x cubed x, then that's going to give us y equals y over x cubed plus x. And then this one will be the C1, and I'll move the A over. And so I'll put the A over here, which I think that's what I was intending to do before, and I messed that up. And then I'll put the C1 over here. So we just put everything here. just be sure I didn't mess it up again. So I divided by this right here, and that became just C1. Then I divided this by this and got A like that. And then so now, let's go ahead and make our table. And to original data had small x, small y was 218, 459, 7160, 9250. And so again, what I've done here then, oh yeah, and then so this is going to be our capital Y, and this right here will be our capital X. Let me put those down. And so that'll be these values here. And I'll just kind of write them here so I don't mess the paper up too much. So when we put the values of X in here, if we put X squared divided by the square root of X cubed plus X and divide that out, we get 1.265. Oh, sorry. Put that in the wrong thing, 1.265. And then when we put these this X value into here, we get 1.94. And when we put this X value into here, we get 2.619. And then finally, when we put this X value into here, we get 2.9816, like that. Then for the Y, I better write it down. So our Y is going to be our small y divided by X cubed plus X, like that. And when you put this Y value in and this X value in, you get 5.692. The next one is 7.155. Next one is 8.555. And the next one is 9.22, like that. So these capital X and capital Y, these are the values that you will put in Excel. And when you do that, you'll end up with a slope is going to be, say your M value is 2.0541. And your Y-intercept, I'll put it over here, is 3.128, like that. And so again, go back and put these into our big equation. So again, remember we called this our capital Y and this our capital X. Let me just write those down again. So what we end up having was capital Y equal, just leave that A there, capital X plus C1. And of course, in this equation, the capital A is going to be our slope, and the C1 is going to be y-intercept the way it normally is on a linear equation. It'll be y equal mx plus b. So then, but now our capital Y was this quantity here, so we'll replace that. Again, we found our y, our slope was 2.0541. And then we replace our capital X with what we had up here, x squared over the square root of x cubed plus x, and our y-intercept was 3.128. But finally, we wanted an equation. The equation we were working with originally, was this y equal equation here. So let's multiply through by this denominator. We multiply through by that denominator, we will get, again, these will end up canceling. We have 2.0541 x squared. Then we'll multiply this over here, plus 3.128 square root of x cubed plus x, which is that's the form that we were shooting for. The only difference is I just have these terms reversed. You could put them back in the original way if you wanted. But so our final equation will be this. Like I said, depending what there are some a few little pitfalls in these, but it's always good to check. So whatever answer you get, just test a few of the points, see if they look like they're pretty close to this equation. There can be some cases because maybe somewhere along the way you end up having a possibility of having 0 in the denominator. Sometimes this won't work, but it's sort of a quick way to do something like this. Any questions on any of this? And let me do just a couple more types here. Let me see, because there are some other forms that are a little bit different. And let me just get some more paper. And so let's take a look at one like this. Okay, suppose we wish to fit this data here. So suppose we wish to fit it to an equation uh, like this. Let's say we have y equals e. Let's call this lambda x. So suppose we want to fit something like this. And of course, that doesn't look anything like a linear equation. But of course, whenever you have e to the x and you want to try to get in a different form, always think of using the log. So let's try that. So solution, take the log of both sides. So say something like this. And then of course, remember the log of a product is equal to the sum of the logs. This is going to be log of y equals log of A plus log of E lambda x. And so now, of course, remember the log and E are inverse functions. And let me also just kind of put it over here just to kind of get it where we want it. So again, the log of E to the anything is the anything. So we'll put this over here. That'll give us lambda x plus log of A like this. So this kind of becomes our function because it kind of looks like the function formula we're interested in. This is going to be kind of like our y, and then this case our x will just be x. It'll be just our small x here, and then we'll have our lambda. That's going to be like our slope, and then this log of a is going to be the y-intercept. So again, that's the form that we want, where this is like m and this is a y-intercept. So let's go through our same steps we did before. And so put our data together. We have x, y, and then over here we're going to have like our capital X, which in this case it's just going to be the same as our small x. And our capital Y, in this case it's going to be log y. And so let's go through and do our table. This will be 2, 2.5, 3, 3.54, would be 100, 200, 250, 300, 700. Oops, that wasn't very good. So just like before, go ahead and calculate these. So this is going to be so here again, x is just going to be x, so we can just copy that column right down. And then over here, log of y. And then log of 200 is 5.29. 83. And this one's going to be a log of 250, but not enough room there, so I'll just put the answer, 5.5214. Then log of 300, 5.7037. And log of 700 is 6.551, like that. So once again, put these in Excel. Then from Excel, you get, let's see, what did it come out to be? We got like the slope. Now it'll actually probably give you an equation with the, in fact, I'll show you in a minute. The slope is going to be 0.8591. Then the y-intercept is going to be 2.9584. Like that. Or like I said, it'll actually give you the equation with a small y and x, but what they really mean again is that this is going to be 0.8591 times your capital X plus 2.9584. And then go ahead and put your stuff back in. See what y was equal to the log of y. X was equal to small x. And go ahead and plug those in like that. And then remember, we want to get back to our original equation. So this one here, so we have to take the log of both sides. And, excuse me, we're going to have to exponentiate both sides. We have to take e 0.8591 x plus 2.9584. And of course, this is going to be just y. And then this up here. Now you can, we can actually break these up. You remember, this is the same as e to this quantity times e to that quantity. So you can actually put that in. And so this is going to be like e to the 0.8591x, e to the 2.9584. And then when you evaluate that, that becomes, we'll put that in your calculator, this becomes 19.267. 19.267 times e to the 0.8591x, like this. And again, that's the form that we were shooting for. Any questions on that? Again, this could probably be done, this first one could probably be done in a couple different ways. You could maybe either multiply by x. Yeah, probably maybe multiplying by x would make the most sense. And so again, you know, like when you start this one, you could maybe do, I don't know, maybe xy equals c1 plus c2 cubed. And if you want to kind of make it look really nice, do xy equals c2x cubed plus c1. And that's all. Actually, it's kind of very similar to, actually, that's very similar to the first one we did. The only difference is the left side's going to be different. Then again, this is going to be your capital Y over here. And this will be your capital X. Again, you'll do like have an X cubed column, and then an XY, and go ahead and calculate those and put them in Excel. So you can either do these one at a time or go ahead and set up the table for all of them, then put them all in Excel at one time. It's up to you.